All right, we're going to take just a few minutes before y'all leave. This should be on Moodle. It's 19. And this has absolutely nothing to do with related rate problems, okay? This is one of those things that we start just talking about a little bit now, and y'all are not going to like it because there's no math to do. Oh, no. You just have to think about things, and you have to start piecing together what we already know and visualizing that, okay, since I know this, I know that, and these type things. So I want you to kind of think about what we've learned about so far, being derivatives mainly, okay? So here's the first graph that I have for you on 19, and I just want you to look at it, and all we are asked to do is sketch the derivative of that graph. It doesn't have to be exact, but we need to sketch the derivative of the graph. Not find the derivative at a specific point. I'm not looking for a number to get out of this. I'm looking to be able to sketch. So does the derivative look like a line? Does it look like a square root? Does it look like another u? What does it look like? That's our goal here. So, looking from this. Now, Mr. Douglas says it looks like a line. Why do you think so?
Parabola there, and mathematically that would be x squared, so if you took the derivative of that, it would just be like 2x.
Okay, so he's going on the assumption that this looks like a parabola, which I would agree with him. So it's going to be something x squared, I would agree with. So the derivative is going to be 2x something, I'd agree with that. So it's going to be a line. But we need to get a little bit more specific than that. For example, can you tell me where the derivative crosses the x-axis? At so where does the derivative, not the function crosses the x-axis at 2 and at -3. I want to know, where does the derivative of the function cross the x-axis?
It would be like
-1. Why do you think so?
Because the middle term is going to be added.
Okay, because if it's in the middle, kind of, okay?
No, because if you multiply, it's going to...
Because if I go 1, 2, 1, 2, it's going to be somewhere kind of between them is what you're thinking. Yes, where is this going to cross the x-axis? All right, now, let me ask you this. What does it mean? All right, let's chase it this way. Tell me a point on the graph that you know exactly what the derivative is. Or if you want to draw it up there, somebody go up there and draw. Can you tell me somewhere where you absolutely, positively, 100% know what the derivative is?
Wouldn't it x equal to -1?
Here it'd be -1. It would be negative, I would agree with. I don't know that it's -1. Tell me where the derivative is 0. Let's go that route. At the very tip top, right? The derivative is going to be 0 right there. Would you agree? So if the derivative is 0 there, that's where the derivative crosses the x-axis. So we know then that our derivative is 0 somewhere right along in there. Okay? Now, is the derivative 0 anywhere else? Nope. Why not? Bless you. Why is the derivative not 0 anywhere else? Okay, because what's true at the x-axis? Hold on. Yes. All right, let's see. This is where it gets tricky here. That point there is what? 0, -1/2. Would you agree with that? So that means if this is x, no, it's not. It's -1/2 0, isn't it? Okay, thank you. It's -1/2 0. What does that mean? That means when the derivative, when x is 1/2, -1/2, the derivative is 0, because that's what we're drawing right here. Now, the derivative, y'all said, is 0 nowhere else. How do we know that the derivative is not 0 anywhere else? It doesn't have a tippy top, or it doesn't have a tippy bottom anywhere else. It doesn't have a max or a min anywhere else. Okay? Now, so then what does that tell you? If it's never 0 again, tell me about the derivative from this point to the right. It's either negative or positive. Don't know which, but it's either negative or positive. Tell me about the derivative from this point to the left. It's either negative or positive. So, now, based on what Mr. West said a while ago, what do you think the derivative is right along in here? Negative or positive? Negative. So what does that tell you about every point? Since that line is to the right of negative 1/2, what does that tell you about the derivative to the right of negative 1/2? It's negative. So we have a line. Now, does it go down like that? I don't know. It might go like that. It might be slanted like this. It might be less steep. It might be more steep. But the bottom line is we know it's a line that looks something like that. Talk to us about the other side of it. What's the derivative over there? Positive. So then over here, the line would be up, something like this. Yes, this is the derivative of that line, okay? That is the derivative of our initial curve. Is it exact? No. We know that it has that general shape. It might be tilted a little differently than that, but that's going to be the basic look of it right there. Yes. This is position, what was given. Now we just found velocity. Very good. Now if you look at this red line, and we're about to do the same thing again. Draw the derivative of this red line. So we're looking for the second derivative. I would always recommend, where is the red line have a slope of 0? Nowhere. So that means that the green line is either always positive or always negative. And when you look at the F prime, it is a falling line, so it's going to be negative. So it's going to be a negative line somewhere down here. Do we know it's right there? No, we don't. It might be at -2. It might be at -1. It might be at negative pi. That's right. We don't know where, but we do know that at least that it is negative in that respect, okay?
Could we figure out the y-intercept
of
F1?
Of F prime? Only if we knew exactly what the slope was and what that point was there.
Well, could we figure out we have the intercept? We have the zeros?
If we've got the zeros, we could probably figure it out in this case. So we could get exactness here. But really what we're focusing on right now is not exactness, it's an approximation to it. That's really all we want you to do. Let's look at a couple of other examples that maybe are not as familiar to you. For example, when you look at this graph, it probably doesn't jump off the page to you for what it is. It could be a cube, but the flatness of it in here tells me it could be an x to the 5th or an x to the 7th, or it's x to an odd power is all I can tell you. All right? But we're going to start off the same way. We want to graph the first derivative. Okay? Where is the first derivative 0? At -2. So we know that the first derivative crosses or touches the x-axis right there. Is the second derivative, is the first derivative 0 anywhere else? And again, how do we know it's not 0 anywhere else? It doesn't have it's not straight. It doesn't have a horizontal tangent line. right here on the graph we have a horizontal tangent line. So we just need to figure out, okay, what's happening to the right of 2? Talk to me about the slope all over here to the right of -2. What is it? It's a positive number, and it's getting really big really fast, isn't it? So it's going to be something like that. Well, talk to me about the slope over here to the left of -2. Wait, it's positive, isn't it? So what does that mean it looks like? It's going to kind of look like a parabola, isn't it? Because it's positive over here, and it's positive over here. Now, let's talk about the positiveness of this. I don't know if that's a word or not, but it is for me. Looking right here and looking right here. Let's say we're looking at a point here and a point up here almost at -2. Both of them are on the left of -2. The slope is both of them is positive, right? Which one's more positive? Is this one or this one? The lower one being this one down here? Yes. So that means that the slope is way up here, and the slope is getting lower and closer to 0 as we get closer and closer to -2. Because right in here, its slope is positive, but it's a real small number compared to this number here. Do y'all follow that? Okay. See if you can figure out what the second derivative looks like then. The first derivative looks something like this parabola. It may be wider, it may be thinner, but it's going to look something like that parabola. That's the basic shape of it. Now that you've got the basic shape of it, what's the basic shape of the second derivative? Go through those same steps in your mind. Where is the blue line have a slope of 0?
So would just that be the derivative, or would there also be a line that was going down the opposite direction from the bottom?
No, sir. That's the derivative right there.
The derivative is both.
Yes, yes. There's only one function for the derivative, and it's going to look something like that there. It's probably not going to be that exactly, but it's going to look something like that. Now, looking at that, see if you can figure out where you think the second derivative is 0. Same spot. Okay. Is the second derivative 0 anywhere else? No. Okay. Talk to me then about the second derivative to the right of -2. Again, what's the slope of the blue line to the right of -2? It's a what kind of number? Positive number, and that positive number is getting bigger the further to the right I go, isn't it? So it's going to be a positive number, and it's going to keep going up and up and up like this. Talk to me about the slope over here. It's a what kind of a number? Negative number, and it's really negative the further out I go, and it gets closer and closer to 0. So it probably looks something like this. Now, we're going to learn a few more tricks later that tells us that it doesn't do any loop-de-loops in there in between. But for right now, just hold on to that much information there, okay? Good. Good. Y'all seem to be digesting this better than I anticipated. I like that.
Okay, 2 zeros.
Okay.
A scientist.
Where is, yes, I do believe it is. But look, always go at it the same way to begin with. Where is it 0? Well, right there and right there. Our slopes are 0, aren't they? So that means that our first derivative is going to cross the x-axis in these two places. So now we've got to figure out what's happening with the first derivative before pi over 2. Well, if we look at that, what's happening to the curve? It's going up, so it is a positive. So that means that our first derivative is positive in here. Now, Is it straight or is it curved? Well, it's kind of hard to tell. I can't, it'd be hard to argue either way right now. Let's just leave it like that, and we'll try to fine-tune it here in a second. Probably as we put more stuff in here, we'll figure that out. Okay? Talk to me about the first derivative from this high point to this low point. It's negative, but now let's see. It's 0, then it's negative, it's more negative, and then it's back to 0. So what does that indicate to you that it's going to do? It's going to start off, it's going to be negative, but then at some point in time, it's got to come back around so it can come back up to this 0 point, right? Now, does it do that? Does it do that? Really, without a lot more technical data, we don't really know that, but it's something basically like that there. And then what's happening from this point forward? It starts off at 0, then it gets a little positive, then it gets more positive and more positive and more positive. Now, if you look closely, you'll probably see that this line starts bending a little bit. So what does that mean to you that when it starts bending? Probably, it's still going to be positive, but it's probably going to start going back down. So now the fact that these are curved kind of indicate to me that this would be curved too. So we're thinking that it's going to look something like this. And if you remember that this right here is the sine curve, the original f function was, then you would know that this blue function right here is the cosine curve. So now take the second derivative and draw it. You expect it to be the negative sine curve. So see if you can figure that out. Second derivative. Where is the blue line have a slope of 0? At the bottom, which is this point right here. And then talk about what's happening to the blue line from beginning to that point there. It's negative, and it's going to be moving up towards 0. Would you buy that? So it's negative, and it's moving up towards 0. And then what's happening from here on? It's positive. Starts at 0, but it goes positive, but then it starts going back. Still positive, but going back towards 0. So it's going to do something like this.
Down after this is the 0 part, so it starts to become a positive increase in like the negative number if you're looking at position of velocity. And that would explain the curve right there for the cosine.
Yeah.
Cosine curve.
For the cosine.
So we would assume once it hits the 0 point, it's increasing going backwards. Does that make sense?
Yes, I think you're saying that right. Yes, it's going backwards. It's increasing.
It's like reversing.
Yes. We stuck it in reverse and we're backing up.
So you're going like a positive increase in speed.
Yes.
So it would make it go back up.
Right, because yes, you put it in reverse, but you're still rolling backwards.
Yes.
So you're still moving backward, but you're moving backwards slower because you're trying to move forward. Is that what we're saying?
No, I'm saying like when it goes, if you're assuming like the x is the 0 and you're doing like a position,
okay.
And you go from like the top where we were at like 4, you would go down. So that would be like a decreasing speed.
Okay.
And then once you hit 0, you speed back up, but you're going in like reverse.
Yes, you speed back up. Your velocity is increases because now your velocity is still decreasing here, isn't it?
No, I'm talking.
If the black line is your position.
Where it's a line going straight down that we're doing the.
Here.
From 4 or from like pi over 2 to 3 pi over 2.
Pi over 2 to 3. So you're talking about this loop right here. Yes.
How do you get the change at that midpoint?
How do we know that that's changing there? Okay. Because.
That's the origin where the line changes from positive to negative.
Yes. So, okay, so let's talk through this blue line as a velocity, okay? This velocity says that this velocity is positive. What's true of the velocity when it gets to this point right here? It's 0. Okay, so my velocity is positive. I'm moving forward, but when I get to this point here, my velocity becomes 0. Okay, so I have stopped here. Then my velocity becomes negative. Okay, so I'm backing up. Now, what happens right here? My velocity is still negative, but I'm slowing down in my backing up. I'm still, all right, so I'm standing right here at pi over 2. I'm standing right here at pi over 2. So I'm backing up, and now when I get to pi, I'm still backing up, but I'm slowing down about my backing up. Okay? And now when I get to this 3 pi over 2, I stop, and I'm headed back forward. Okay?
Wow. I'm surprised.
Yes, sir.
Why would the third one start at 0?
Why wouldn't the third one start at 0? Okay? If we know that this is 0 up here, then yes, it would. Actually, it should do something like this. It should do this, is what we should be able to see out of it here. It should do that right, what should it do? It should do that right there, is what it should do. But it's hard for us to know. We don't have any data looking at it to know that it's zeroed out right there. That the slope would be 0. If we had a bigger piece of this, then yes, we could say that. You're going on that conclusion because you know that the black line was sine, so then the blue line is cosine, so the red has to be negative sine. And I get that. That's good information to have, but really we can't know that without having some data that to look at, okay? All right, I know that it's time for those of you that are leaving to go on to the ball game, so we will pick up